On October 19th, 2017, a telescope in Hawaii detected something that had never been seen before, an object moving through our solar system at 87 kilometers per second. At first, astronomers thought it was just another asteroid or comet, but the orbit did not fit. This thing was not bound to the sun at all. It had come from deep interstellar space, sliced through our neighborhood, and was already on its way out. It became the first confirmed interstellar object ever detected passing through our solar system, and it earned a perfect name, Oumuamua, Hawaiian for scout, or messenger from the distant past. What made it so unforgettable was not just where it came from, but how bizarre it was. Based on the way its brightness flickered as it tumbled, Oumuamua seemed extremely elongated, 5 to 10 times longer than it was wide, like a cosmic cigar or even a flattened pancake, somewhere between roughly 100 and 1,000 meters long. It was dark reddish, like outer solar system objects weathered by cosmic rays, hinting at an ancient journey across the galaxy. Yet unlike a comet, there was no visible tail, no coma, no obvious outgassing. Then came the twist that set astronomy on fire. As Oumuamua sped away from the sun, it accelerated ever so slightly, more than gravity alone could explain. The push was small, about 0.00001% of Earth's gravity, but it was steady and real. Comets can do this when they vent gases that act like tiny rocket engines, but telescopes saw no visible jets at all. So what was pushing it? Scientists offered a slate of bold ideas. One mainstream idea said outgassing was happening but was invisible, maybe driven by pure hydrogen that would not show up like typical comet jets. A 2020 study suggested a hydrogen iceberg, formed in a giant molecular cloud, could sublimate and provide thrust without a visible tail, though skeptics note such icebergs should be too fragile to survive the trip. Another team proposed a nitrogen ice fragment chipped off a Pluto-like exoplanet. Nitrogen sublimation could explain the acceleration and even help account for the odd shape if erosion flattened it over eons. Others floated a truly exotic possibility, a light sail. In 2018, Avi Loeb argued Oumuamua might be artificial, a thin, flat sheet pushed by starlight. A light sail would not need outgassing and could match the acceleration. Most astronomers pushed back, saying extraordinary claims require extraordinary evidence, and that natural explanations, while weird, remain more likely. There was even a dust bunny idea, a super low-density clump of particles so fluffy that sunlight could nudge it like a feather. But could such a fragile object survive interstellar space? Halfway point question time. Which explanation do you find most convincing? Hydrogen iceberg, nitrogen ice pancake, light sail, or dust bunny? And why? Drop your take in the comments so we can debate the best fit for the data. Here is what we know for sure. Oumuamua swept in from the direction of the constellation Lyra, passed relatively close by Earth, reached its closest point to the Sun in early September 2017, and is now heading toward Pegasus. It gave us only a few precious weeks of observations before fading into the dark, too distant and faint to study further. The most frustrating truth is that we will never know exactly what it was. We did not have the instruments ready, and we did not get close enough, but that fleeting visit changed the game. The next time a visitor like this appears, we will be prepared. The Vera Rubin Observatory is expected to find interstellar objects far more often, and astronomers are building faster follow-up plans to capture spectra and shape data immediately. There is even a proposed European mission called Comet Interceptor, designed to wait in space and pounce on a future interstellar target for a close-up encounter. If you love the chase for cosmic outlaws like this, hit subscribe for more mind-bending mysteries and real-time discoveries. Oumuamua will remain a riddle, a messenger whose message we were not quite ready to read. But it forced us to ask better questions, sharpen our tools, and admit that the universe still throws curveballs we cannot predict. The only thing scarier than an interstellar visitor we do not understand is the next one we almost miss. When the next messenger arrives, will we finally catch it in the act?